So the objective of this lesson is to help you understand how to solve a system of linear inequalities, and we're going to solve each of these systems using the graphing method. So you should be familiar with how to graph the line y equals 4x minus 3, and we're going to go ahead and do that first, and we're going to be careful here because when we graph y is greater than, we have to make sure we draw the line, the border of this region with some dashed. So this is going to be dashed because I'll talk about that in a second. But the first thing we want to do always is to draw the line y equals 4x minus 3. So we know that line has a y-intercept of negative 3, and it also has a slope of 4 because it's in slope-intercept form. So we go up from any point on the line, which we'll pick the y-intercept. We go up 4, 1, 2, 3, 4, and over 1, and we place another dot. That's all we need, 2 points, to draw the graph of a line. Now again, like I said, we're going to draw the line with a dashed, we're going to draw a dashed line, because what's happening here is what we're trying to do is we're trying to draw the graph of y is greater than 4x minus 3. So as long as the variable y is on the left-hand side, and that variable y is greater than this line, it means that from the line we're going to shade the entire region above the line because it says y is greater than. So the y values are greater than that line right there. And so in shading that side, we're going to go ahead and shade it kind of lightly. So we can see we have that side of the line. In fact, it would be important to understand and be able to interpret. Now, drawing the solution set is our learning objective 2. Interpreting the solution set is the learning objective 3. So interpreting what we've got here, we've got all the ordered pairs shaded that would make the first inequality true. I can't stress how important it is to understand what I just said. And I'll say it again. What we shaded here is all of the ordered pairs that would make the inequality true, the first inequality true. For example, we shaded 0, 0. So 0, 0 is in the shaded region. Okay, so we can check to make sure we shaded the correct side by replacing x with 0 and y with 0 as well, because 0, 0, it shows that 0, 0 is shaded. So let's just go ahead and check 0, 0 here. Checking 0, 0, we replace y with 0 and x with 0, and we get a statement that says 0 is greater than negative 3. Well, that's a true statement. 0 is greater than negative 3. Well, that's why we shaded 0, 0. Likewise, we could try any ordered pair in this region, and it would make that inequality true. I urge you to try one on your own. Now, we could also try an ordered pair that's actually on the line, on the border of the region, I should say. The line that we drew dashed shows that that's the border. So anything that's not shaded, anything to the kind of like right and under of the line is not shaded. So those ordered pairs would make the inequality false. But we're first going to try this ordered pair right here, 1, 1. So if we check 1, 1, we replace y with 1 and x with 1. And we get the statement 1 is greater than 4 minus 3, which is 1. Well, that's why the dashed line shows that no ordered pairs actually on the line make the inequality true. If that were so it barely makes the inequality false, but it still makes it false because 1 is not greater than 1. If by chance that was a greater than or equal to, which we'll see in the other one, if that were greater than or equal to, we'd make it a solid line. The solid line acts just like one of those solid circles when we want to include the endpoints. Well, the solid line means we want to include all the points that are on the line. So let's check one more. Let's say 5, 0. 5, 0 did not get shaded. That means that when x is 5 and y is 0, that ordered pair does not satisfy the inequality. So if we try 5, 0, we would replace x with 5 and y with 0. So we put the 0 in for y, greater than 4 times 5 minus 3, and we can see that 0 is not greater than 20 minus 3, which is 17. That's false. I also forgot to write false here. So we've shown 3 points, one that's on the border that makes it false, makes the inequality false. We've shown one that's in the non-shaded region that also makes the inequality false. And we showed an ordered pair that is in the shaded region. So we've double and triple checked that what we've shaded is accurate, shading all the real I shouldn't say real numbers, all the ordered pairs that make the inequality true. I'm going to go ahead and stop this video and finish this problem in the next video.